Volcanoes are among the most fascinating and powerful forces of nature on Earth. But what exactly causes them to form and erupt? To understand volcanoes, we have to begin deep beneath the Earth's surface, far deeper than any man has ever gone. At the center of our planet is the core, surrounded by the mantle, a thick layer of hot, semi-solid rock. The extreme heat in the mantle, caused by leftover energy from Earth's formation and the decay of radioactive elements, melts some of the rock into magma. Magma is a hot, molten mixture of rock, gases, and minerals that is constantly shifting and moving. Now, Earth's outer shell, known as the crust, isn't one solid piece. It's actually broken into large slabs called tectonic plates, which float on top of the softer mantle layer. These plates are always moving, though very slowly, only a few centimeters each year. Volcanoes are closely tied to the movement of these plates. In fact, most volcanoes form at the boundaries where tectonic plates meet. These plate boundaries are where some of the most intense geological activity on Earth happens, including earthquakes, mountain formation, and, of course, volcanic eruptions. There are three main types of plate boundaries where volcanoes can form. The first is a subduction zone, where one tectonic plate slides underneath another. This usually happens when an oceanic plate meets a continental plate. The heavier oceanic plate sinks into the mantle, where it melts and forms magma. This magma is lighter than the surrounding rock, so it begins to rise toward the surface, eventually erupting as a volcano. A good example of this is the Ring of Fire, a horseshoe-shaped zone in the Pacific Ocean where the majority of Earth's active volcanoes are located. The second type of boundary is called a divergent boundary. This is where tectonic plates are moving away from each other. As the plates separate, magma rises up from the mantle to fill the gap. This type of volcanic activity often occurs on the ocean floor, creating underwater volcanoes and new crust. Over time, these can even build up into islands. Iceland is a unique example of a landmass formed largely by volcanic activity at a divergent boundary. The third scenario is a bit different and doesn't depend on plate boundaries. These are called hotspots. A hotspot is an area in the middle of a tectonic plate where magma from deep within the mantle rises up through the crust. This creates a chain of volcanoes as the plate slowly moves over the hotspot. The Hawaiian Islands were formed this way, one after another, as the Pacific plate drifted over a fixed plume of hot magma rising from deep inside the Earth. Now that we know how volcanoes form, let's talk about why they erupt. As magma collects in chambers beneath the Earth's crust, it contains dissolved gases like water vapor, carbon dioxide, and sulfur dioxide. These gases are under extreme pressure. As magma rises, the pressure decreases, allowing these gases to expand rapidly, just like a bottle of soda when you shake it and then open it. If enough pressure builds up, it eventually breaks through the Earth's surface, causing a volcanic eruption. Not all eruptions are the same. Some volcanoes, like those in Hawaii, have gentle lava flows because the magma is runny and allows gases to escape easily. Others, like Mount St. Helens or Mount Vesuvius, can explode violently. These eruptions happen when the magma is thick and sticky, trapping gases until they burst out in a massive explosion, hurling ash, rocks, and gas into the sky. The type of eruption depends largely on the composition of the magma, including its temperature, viscosity, and gas content. Volcanoes can have a major impact on the environment and on human life. In the short term, they can cause devastation. Lava flows can destroy homes and land, while ash clouds can ground airplanes, collapse buildings, and cause respiratory problems. One of the most tragic examples in history is the eruption of Mount Vesuvius in AD 79, which buried the Roman cities of Pompeii and Herculaneum in ash. In more recent times, the 2010 eruption of Eyjafjallajökull in Iceland caused massive disruption to air travel across Europe for several weeks. But volcanoes also bring benefits. Volcanic soils are rich in minerals, making them very fertile for agriculture. Many people live near volcanoes because the land is good for farming. In addition, volcanic activity is a source of geothermal energy, a clean and renewable resource that provides power and heating in countries like Iceland. Volcanoes also play a role in forming new land and maintaining Earth's carbon cycle, helping regulate the planet's climate over long periods of time. Scientists today work hard to monitor volcanoes and predict eruptions. They use tools like seismometers to detect earthquakes, gas sensors to measure volcanic gases, and satellites to observe changes in the landscape. While predicting the exact time and size of an eruption is still difficult, early warning systems have saved countless lives by helping people evacuate before disaster strikes. Some of the most closely watched volcanoes today include Yellowstone in the United States, Mount Fuji in Japan, and Mount Etna in Italy. In conclusion, volcanoes are a dramatic result of the Earth's inner forces at work. They form primarily due to the movement of tectonic plates and the heat from the Earth's mantle. While they can be dangerous and destructive, volcanoes also contribute to life on Earth by creating new land, supporting ecosystems, and providing resources. Understanding the reasons behind volcanoes not only helps us stay safe but also deepens our appreciation of the dynamic planet we call home.